In the world of science, following years of speculation and studies, a revolutionary discovery has occurred: the first identification of a white hole. But what is a white hole? Why has this discovery garnered so much attention from astronomers, and what impact will it have on your life? Keep reading to discover more about the discovery of white holes. You've certainly heard about black holes, massive and fearsome objects hiding in the depths of the universe, swallowing everything that comes near. But there is also a phenomenon opposite to the black hole, known as a white hole, which is just as terrifying. To better understand a white hole, it's essential to understand the formation of black holes, as many of their characteristics also apply to white holes, but in reverse. Black holes can have different sizes, but there are mainly three types: primordial, stellar, and supermassive black holes. The type of black hole depends on its mass and size. Primordial black holes, for example, are the smallest of atomic dimensions, but with the mass of a large mountain. The most common are stellar black holes, which can have a mass up to 20 times greater than that of the Sun. Despite their mass, they are relatively small and can easily fit within a sphere with a diameter of about 10 miles. Lastly, supermassive black holes, the largest ones, weigh more than 1 million suns combined. These supermassive black holes, despite their mass, can fit within a sphere the size of the solar system. It is believed that every large galaxy contains a supermassive black hole at its center. The supermassive black hole at the center of the Milky Way, known as Sagittarius A, has a mass equivalent to about 4 million suns. Black holes are born in different ways. Primordial black holes form shortly after the Big Bang. Stellar black holes form when the center of a very massive star collapses in on itself, causing a stellar explosion or supernova. Supermassive black holes, on the other hand, form concurrently with the galaxy in which they are located. While a black hole can't be seen due to its strong gravity, which doesn't even allow light to escape, scientists can observe the effects of its gravity on the stars and gas that surround it. They can study the movement of a star orbiting a point in space to determine if it is orbiting a black hole. When a black hole and a star orbit closely, high-energy light is produced. But what does all of this imply for our Sun? Fortunately, our Sun does not have enough mass to collapse into a black hole. However, the Sun does not escape death. At the end of its life, it will become a red giant, and once its fuel is exhausted, it will shed its outer layers and transform into a cooling white dwarf. And now, we get to white holes. A white hole is the exact opposite of a black hole. It is a black hole seen backward in time. A white hole is a region where space-time flows relentlessly outward. White holes are thought to emit light, radiating at levels comparable to the strength of a black hole. The idea of white holes first emerged due to mathematical fascination with black holes. Albert Einstein, in 1905, concluded that objects with mass have gravity, which is a distortion of time and space rather than a real physical force. Carl Schwarzschild used Einstein's field equations to find the equation of mass in a vacuum spacetime, resulting in what is known as the Schwarzschild metric, a mathematical representation of a black hole. Despite this, not all scientists agree that white holes exist, making the recent discovery all the more significant. Some scientists argue that just because a white hole respects general relativity and is mathematically correct doesn't mean it's practical. This is due to the fact that white holes would seem to violate the second law of thermodynamics, which states that entropy in the universe must always remain the same or increase. Entropy is often described as chaos, but can be better understood as an increase in the number of possible states for particles in a given system. Despite these controversies, the recent discovery of a white hole has demonstrated that these phenomena might indeed exist. In 2006, NASA's SWIFT satellite detected a powerful gamma ray burst named GRB 060,614 in a very strange region of the sky. This gamma ray burst was not associated with any stellar explosion, but it lasted a notably long 102 seconds. Several years later, scientists speculated that GRB 060,614 might have been a white hole. This discovery opens new perspectives for understanding our universe and raises fascinating questions about the nature of time and space. Let us know what you think about the existence of white holes in the comment section below.